I was watching the High Performance Graphics conference and heard about neural materials, and I don't really know how they work, so I figured I'd give it a try without doing much research and see how it goes. Just a major caveat, I didn't really research this, I just did something for fun. Don't base your whole understanding of neural materials on this video, and take everything in the video with a grain of salt. In a normal material pipeline, we take some textures, do some math with them involving the light and the camera and so on, and then you get a pixel color out. Depending on your material, there might be a lot of texture data, the math could be expensive, and if you have very different materials, you're going to need wholly different shaders that do different math. With a neural material, as I understand it, the idea is that you replace the entire bit of math and the textures with a latent space texture that encodes somehow the information about the texture, and then you replace the math with a neural net. And so during rendering, you just take your latent space sample, you run it through the neural net together with the lights and the camera position, and you get a pixel color out. So unlike the regular materials, this could be very uniform, and the latent space is kind of a compressed representation of all the textures, so it could use fewer channels perhaps. To generate the latent space, we also have a second neural net that encodes the regular textures and how our shader works into the latent space texture. But that neural net only runs offline before we start the actual rendering. To do this performantly, I think you actually want an upcoming extension called Cooperative Matrix, but the support for that one is kind of bad right now, and you can literally just do a neural net in a regular shader, so that's what I did. So to try this out, I used AI to whip up a quick neural net for the encoder and for the material in Python. I then implemented a PBR shader in Python so that I could generate training data pairs of light position, camera position, and texture data to feed into the model, as well as what pixel color it should generate. Then I trained that model, and I wrote out the latent space as a texture and the weights as a long array to feed into the shader. The shader then simply does a couple of matrix multiplications. I've also pointed out, you can see the ReLU activation function at the end of each layer. Taking a quick look at the results, it doesn't look that great, but you can kind of see the basic idea of it. I like how it's reproduced the angular math of the light direction pretty well. However, the colors are kind of off. Maybe that's because I used only 2 channels for the latent space and it just isn't enough to encode the right colors. Maybe it's because I should have used like a perceptual loss function that actually minimizes the distance from an HDR color to another HDR color in a way that makes them look similar rather than just being numerically close. I'm not entirely sure. Maybe the neural net is too small and it can't accurately represent it. But nevertheless, it kind of shows the idea, so I'm happy with that. Some difficulties, though, that I sort of foresee is, like, how do you do things like many lights? I mean, many lights is not so difficult because you would just compute them additively and add them up. But what if you want to sample some directional information, like a cube map for a reflective material? Your neural net would have to tell you the direction that you want to sample, and then you'd have to run the neural net again to get the information back out. It seems that you'd be walking away from the uniformity that I might give you, so I'm not sure how to integrate that correctly. In terms of performance, it's also like 3 times slower than the regular PBR shader, so for PBR it's not worth it, but for a very complicated material maybe it would be. Of course, with the hardware acceleration that I didn't use, things would be different. Also, there's a related idea called neural texture compression, where instead of computing the pixel color with a neural net, you take the latent space and a neural net to get the texture data back out, and then you run your regular shader on that. That might be better fit for typical materials, really. And it slots more easily into regular pipelines. And it lets you use a greater total amount of textures, so that seems kind of nice. Still, that's also going to need hardware acceleration, which isn't there. So I'm just going to leave you on the monkey again. Not really passable, but kind of interesting. Fun experiment.